comet Dennin Fujikawa appears every 9 years and was last seen in the year 2005. That was before you were born. So you missed it. Like, best time of my life. Oh, just kidding. I didn't see that. Okay? Well, last seen in 2000, every 9 years, hey, wait a minute, this book's too old. It was last seen in 2005. Maybe 2014 was cloudy. Maybe that's why. And 2023, we missed it 2 years ago, was also cloudy. But according to this, set your calendars, right? If it was every 9 years, that means we saw it in 2005, 2014, 2023. Set your calendars. 2032, take the whole year off, just wait for the comet. Plan your life around it. Now, if you miss it in 2032, but happen to become immortal, you now wonder, could I live to the year 3085 and actually see it? In other words, in this sequence, we're wondering, is that number included or not? So again, a little bit of problem solving. The strategy that would work that I wouldn't recommend is keep writing out the numbers until you get to 3085-ish and find out if that number is right or wrong. That's a lot of numbers to write out. So I don't think we want to do that. But do you see that that strategy would work? It just might take a long time. But if you're immortal, hey, you got all the time you want. May as well do that strategy. What else are you going to do in your time? Like you lose the, so much to do, so little time. That expression is gone for your life. So little to do, so much time now becomes your new model. Okay. So, unfortunately, morbid, we're all going to die. We're not immortal. We better find a fast way to do this so that we can enjoy some other things as well. So, what do we know? We could say that we know that term 1 is 2005. And we know that our d value is 9. What this question is asking is asking, is there a term that is 3085? Is there a nice n? It can't be term 37.6 because that's not a term. So our n, is there an n value? And the n value has to be a whole number. Does that make sense? It can't be a decimal. We could even, if you want to know the fancy math way of writing this, n has to belong to the natural numbers. It can't be a decimal. Is there an n value that makes this work? Well, we know from our formula sheet that our formula for this one would be 2005 is term 1. The d value is 9, and minus 1. I think this is one where I wouldn't want to use the shortcut method just because the numbers are so big to work with that the mental math doesn't make it shorter. So I'll just use the actual formula. Then if we plug in 3085 for term n, we could solve for n. I'm going to distribute that 9, so I get 9n minus 9. Oops, don't need that bracket anymore. So can you see that you have some like terms? You can move the 2005 and the 9 to the other side. So if I take 3085 and I subtract 2005 and add 9, I get 1089 equals 9n. And if I divide this by 9, it's not a decimal. So we can say right? Some of you might be planning to become immortal, right? Start your bucket list. Add to the bucket list, comment, what is it? Dennin Fujikawa on your bucket list now. Before I live to 1,000,000. You have different bucket lists, right? Because you're immortal. You have like the before I'm 1,000,000 bucket list, things I have to get done. Before I'm 1,000,000,000,000 bucket list. Like all of these things you'd have to do. Okay, so questions you can circle at the top of this one. Number 14.